Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week, I spoke with Karthik Kannan, co-founder and CTO of Envision, a company that builds on top of the Google Glass and uses augmented reality features of phones to allow visually impaired people to better sense the environment or objects around them. Their software and devices are pretty popular, and as you'll hear in this conversation, they've been on a real journey to get to where they are now. In particular, I really enjoyed the parts where Karthik explained their development and deployment process in detail. It's not too often that you get to go into a deep dive into the workflows and stacks of an embedded computer vision company and tool, and so I think you're really going to enjoy this one.
So, my name is Karthik Kannan. I am the founder and CTO of this company called Envision. How I ended up starting Envision, it was basically I had a background in software engineering. I finished my bachelor's back in India in 2013, and ever since 2013, I've been working primarily in backend, and then I switched to product management, and then just before I was actually starting out on Envision, I was primarily, I was primarily in the backend space, basically, right? So I kind of became like like I started off in backend in 2013. I was primarily working in Clojure, which was a very interesting, choice for the company that I was working for, because most people were, when you think about backend, you think about Python, you think about that stuff, but then they had a very opinionated take, and they felt Lisp and Clojure was the way to go. I started primarily working Clojure, and then at that point, I was working at a startup called HelpShift, and right after that, I wanted to really start exploring the big data space that was really becoming a hot thing in 2014. It was still not machine learning and stuff like that, but that gave me like direct exposure to what was happening in machine learning. And I first started off playing around with AlexNet and all of those kind of very early stage models that were happening at that point in time. I mean, I can date myself here a bit. I was really in the community when Theano was like a big deal, before TF and PyTorch and all these guys. Yeah, there was Theano, and so I started to explore because I was working at an e-commerce company in India, which was basically building something like Shopify, but for an Indian audience. That was basically what they were doing, and so I was working in the back end, the big data side of things, trying to build these recommender system plugins that we could cross sell to the people who are building stores on our platform, right? So that was my first exposure to like machine learning, and I was there for about 3 to 4 years, and after that, I started to think, okay, I wanted to take a break for myself. So that's basically how I started to get into, say, computer vision. I'm not, sort of academically trained in computer vision. I am more of a practitioner, not a researcher. And so I started to explore computer vision in detail, like in 2015, 2016. At that point in time, Kaggle was still really, really new, and I was very, very active on Kaggle. Not to look for like job opportunities per se, but just because I was really, really excited and interested about the computer vision space. And so that's how Envision happened, because in 2016, I have my co-founder who's also called Karthik, and we both have the same first name, and he was actually a student at the TU Delft, and the two of us went to a blind school in India to talk to kids who were just passing out of school at that time, about what kind of career opportunities do you have if you are going into, like, the research slash programming space, or he's a designer, so he was talking more about how things are from a designer's point of view. What do designers do? um, and I think the fundamental, conversation was about, solving problems, because that's what a programmer does, that's what a designer does. We all go to work every day and solve different types of problems, and it was just a very harmless question to these kids, as to like what kind of problems would they like to solve. We asked it in a very trivial way, expecting to get very run of the mill answers, but then the answers that came out of the kids, it was very, it seemed like it was the most basic thing to do as a human being, but for them those were insurmountable problems. They said things like, I want to be able to read books more independently, I wanted to be able to go out more independently, I wanted to be able to live independently by myself without having to depend on others. So independence became this sort of common factor in their lives, And it was such a limiting thing for them to not be able to do any of these basic things independently. And so that's how, right after the conversation, we were really shaken by it, because they were these really young kids, and they didn't come from very affluent backgrounds. So the dreams that they had were, like, kind of insurmountable because of the place they were coming from and because of their disability. And so that's when, I was telling him, hey, there are all these really interesting advances happening in computer vision. We're seeing models becoming better and better. We're seeing, at that point in time, TensorFlow was really new, and but you could still, with a little bit of effort, take models and deploy them on device. You could do a lot of these things. And we thought maybe there is a way to bring good design and ML together to solve the problems that they were basically having, right? And that is how, I landed up at Envision, and that's sort of my background. It's.
Yeah. I mean, I guess everything makes sense in retrospect, but probably when you started out, you maybe wouldn't have had any idea that you would end up here.
Oh yeah, for sure. When I was playing around with, computer vision back in 2015, 2014, 2015, 2016, I really had no clue that it would all add up to this. I think it was, back then I was purely focused on trying to keep up with the different papers that were getting published. That time I felt the research was more open. People would share checkpoints more easily. You could talk to researchers at some of the big labs. They were really very collaborative and open. And so my aim was to just take a paper, replicate it, or be able to, like, go ahead and train a few models and try to deploy them onto your phone. At that time, I think, Prisma was this really famous app that would do, should I forgot, like, style transfer. Yeah, so it would do style transfer, and so style transfer was a big thing. So I started writing about style transfer and playing around with it. So it was just, pure exploration without any kind of goal in mind. But I think that's what led me eventually to start working, or giving me the confidence that, okay, what, I could take some of the state of the art research and try to productize it. And that's what, I spent a lot of my time on today as well. Yeah.
Mhm. Before we kind of, I guess, move into a little bit about like how you do things, maybe you could, yeah, talk about exactly what Envision is and what you do and how you help people.
Sure. So Envision is a company that builds tools for people with a visual impairment. So when I say people with a visual impairment, it can be someone who's completely blind since birth, or someone who probably has, like, maybe 10%, 20% residual vision. So it's people across the spectrum. So we build tools that help people with a visual impairment across the spectrum to do things, to do everyday things more independently. Right. So we have, for example, the Envision glasses, which basically is a smart glasses where we build our software on top of the Google Glass, to go ahead and help visually impaired people to read text. So they could read any kinds of text pretty much from any printed surface, recognize faces, recognize objects. You can even make video calls directly from the glasses to a friend or a family member. That's basically what we do. We also have the Envision app. So we initially came out with the Envision app back in 2017, and what the Envision app could do back then was just, take a picture, read the text in the picture, or do like a primitive description of what it sees. And from that point on, we evolved the app, and in 2019 we won the Google Play Award for the best accessibility experience on Android. That same year, we had a chance to talk to Google and ask them about if we can, if they do have any smart glasses in the works, if they can go ahead and share that with us. And they were really kind, and they said, yeah, like, we do have some smart glasses. In fact, it's a reboot of the Google Glass that everybody loves to hate. But this time we're not going to sell it as like a thing that people can buy, but it's going to be more of a device that's sold to enterprises so that they can do stuff like, remote teleconferencing and all those things, right? So basically for companies that have big warehouses. But they were really struck by our application, and also the fact that we won the Google Play Award kind of added a little bit more weight to our claims. And they said, okay, cool. And they gave me a pair of glasses in 2019. I brought that back to the Netherlands, took our Android app, repurposed it for the Google Glass from the ground up, and basically gave that out to some of our testers, and they absolutely loved it. And that eventually became the Envision glasses. So what we try to do is we try to take the state of the art in computer vision, and we try to also see, or we rather start with the problems that people with the visual impairment face, and then we look for solutions in state-of-the-art computer vision, and we really take that research in the open domain, like really productize it, and then deploy them on device or on the cloud, depending on what kind of solutions works best. All in the service of helping people with a visual impairment solve the everyday problems that exist around them using computer vision. So that's what Envision does in a nutshell.
And is the idea at some point, because I know, I mean, there's the much fabled Apple glasses or whatever,
Yeah.
which may not ever come. Is the idea that what you're building is agnostic to the specific hardware that it's on, or?
Yeah, that has always been sort of like the vision when we started Envision. Like the technical vision was to build a platform agnostic solution. In fact, we barely have any platform specific code, any computer vision platform specific code. Most of the work in computer vision that we do when it comes to deployment on device is and will all be in C++. Like that's sort of the common layer that we have. It is Yeah, it's a bit, it takes much longer, of course, to deploy things that way. But tomorrow, if we do have, for example, I mean, today all the computer vision stuff that we have is just one single code base shared across three different platforms. And I'm pretty sure that if Amazon comes out with glasses or Apple comes out with glasses, we can easily take what we have and just put it on those platforms, with some amount of course, we need to build an entire UI and UX around it. That's also 50% of the work. But at least the computer vision stuff is always platform agnostic. So I am hoping they come out with glasses. When they do, we would be fairly ready on the computer vision side with that. Yeah.
Mhm. So, I mean, you started to talk a little bit about that. I'm curious, like, what your like the engineering stack looks like for and kind of how you go about building it among your team.
Yeah. So all our initial research always starts off with Python. So that's basically what our stack looks like primarily. So we're a fully TF company at this point, because TF, TensorFlow was sort of the initial framework that had like a mobile that you could deploy, that you could quantize models and deploy to. Of course, with PyTorch, that has always been around as well, but it was not as straightforward to do it as TensorFlow, right? So our stack is entirely TF based. So we use TF. We started experimenting even now with TFX in the early stages, but TF is basically what we do. So when we want to start working on a problem, in especially when we are working on like a B2C, or like when we're trying to build a product for the consumers, even the computer vision folks are heavily involved at the very earliest stages of building a particular feature or building a particular solution. Because what we do is we actually have people who visit our office, visually impaired users who visit our office. We usually pair a designer and a computer vision person together in those sessions, and they both lead the session equally in terms of trying to understand what the core problem it is that a visually impaired person wants to solve, right? So it starts a lot there. And we determine from that point on as to what is the core technical problem that someone wants to solve. For example, a lot of people who came into Envision early on, they were like, yeah, we would love to, like I read textbooks, and in textbooks they tend to be these tables. And when you talk about tables, it's extremely inaccessible. Especially printed tables are pretty much, it's horrible to read if you pass that through a regular OCR tool. Even if you take the commercial OCR engines, they're terrible at reading tables. So, but for a lot of visually impaired people, they do read textbooks, they do go to work, and all those documents tend to have tables that are very inaccessible for them. So when we start off with that, we start looking at what is the state of the art research in this space, and we try to determine that, okay, that's the core technical problem. And even there, we try to determine what are the constraints. Is it something that people expect to work entirely on device, right? That also influences a lot in how we go about it. And so we start looking at what the state of the art research is, and we usually spend about a few weeks doing just understanding the research, and like trying to build prototypes of the work that's there, or try to experiment with different architectures. And at some point, we kind of, and all of that work is done entirely in Python. We use TF even for at the prototyping stage. um, and even if, yeah, like, I mean, there are some engineers at Envision who are very opinionated and feel like they want to use PyTorch, but then, yeah, like, the work happens primarily in TensorFlow. And so we just get to that point where we build a very simple model, and then, call in the designers also to, like, just, give them an idea of how it looks. Some of the designers we have at Envision are fairly comfortable now with operating Jupyter notebooks, right? So they could just go, to collab and just run the cells and see how the output looks like and so on, and just play around with it a few times. At that stage, from after that stage, what we do is we start, building the early prototypes. And depending on whether something needs to work online or offline, we might start even directly working with C++. Right. So at that point in time, our stack is entirely C++. It's OpenCV C++ and TF entirely on device. And that's when we start building the beta of it. And initially, what happens is, with the computer vision team, all of the C++ work is basically done completely standalone, right? So we're not looking to integrate them right away, into our apps. We do have, like, an emulator environment, which emulates how the glasses looks like. We have a sample project that they can, like, go ahead and plug their code in. So we have different types of sample projects, one for, like, say, object detection, models, one for image classification models. And they know enough Kotlin and enough Swift to just modify some of the input output values. And at that point, we start really building the prototype. And once we build a prototype, we have the platform engineers helping us, go ahead and get that deployed into the app or into the glasses. And from that point on, it's the computer vision team, it's the computer vision engineer, it's the designer, and the users going through an iterative process, where we are really refining the model, we're really refining even the post-processing algorithms or whatever it is, along with the users as they give us feedback. And this usually takes about, like, yeah, could be about 3 to 6 weeks of just pure iteration work. And once that is done, we have a V1 that is deployed. And of course, we're still figuring out the best way to monitor how these ML models work in production, how good they are. It's always been a very tricky thing with the glasses. You can't deploy a lot, like, you can't really deploy heavy more, like, libraries on the glasses. You have to keep things as nimble as possible. The UX is also kind of hard, because sometimes, how do you know if a document is read correctly or not for a visually impaired person, right? Like, they have to, rate the outputs and things like that. And so we try to build some kind of a feedback loop in place. But this is generally our process and our stack. It's not very complicated. And all of our and we now spend we initially were GCP based, but then now we have everything on AWS. We work solely based out of AWS at this point. Yeah.
Okay, interesting. And I'm kind of curious, like, how much do you use and kind of rely on either kind of a bunch of kind of key data sets which came out in recent years, or pre-trained models? Like, I kind of wonder whether, like, Envision exists now because, like, now all of these things are available to people, but I don't know whether that's true or not.
Actually, it is partially true. Where it really helps is the pre-trained models or the architectures becoming more open, right? When we come across newer architectures that get put out, like, for example, something like Efficient Tech, that came out, those really help us a lot. Where we don't get a lot of help is the data. One of the really interesting things in this space, and I think one of the key sort of, I would say, moats that Envision as a company has, tends to be the fact that the data that we have is all from a visually impaired person's perspective. And that helps us build much, much superior AI compared to competitors in the space who might have to rely more on open data sets in the beginning. Because these open data sets, they're all data that's captured from the point of view of a sighted person, right? If you look at a data set like ICDAR, which basically contains a lot of documents that are scanned, those documents are perfectly scanned, top down, cropped, and properly perspective transformed. But if you look at how a visually impaired person captures a document with a phone, it's dramatically different. The angles are very skewed. Sometimes they only capture a portion of the document. And or sometimes the way they capture or the whole their phone is in completely different orientation. So you get different orientation. So all those things matter a lot. And initially, we had to go through a lot to basically, even build our own data sets in some of these areas, like for example, document detection and all those things. We had to invite users to the office, collect data from there. And eventually, when we started to work with user data, we had to work through a lot of stages before we can actually use the data that's coming in from the users, or before really having like our own data set to start working on bigger problems. So what really helped Envision in the early days was definitely the availability of pre-trained models, checkpoints, architectures, and even some of the papers that people wrote that did contain insights into how they do post-processing, for example, when they're trying to scan a table or when they're trying to scan a document. Those things really, really helped Envision in the early days as a startup because, of course, we didn't have the bandwidth to do all that research ourselves. Initially it was just me trying to figure this stuff out. And over a period of time, we've come to rely more on our own data set, plus the advances that are happening in the open field and combining them together to actually solve problems.
Mhm. And from what I understand, like you also allow users to kind of customize, and whether this involves fine tuning or anything, like customize the models for their own particular people in their lives or specific objects and things.
Yeah. So we actually allow people to teach faces of their friends or family members. That's a fairly solved problem at this point. You can go ahead and personalize a face detection model, and have it do a really good job. So we've built our own pipeline where we have the captured faces. We quickly fine tune the model so we have a model per user, and we quickly fine tune the model based on the new faces that they're basically training with Envision, and then we deploy that back onto the device. So we've built an online offline hybrid system to be able to do that. In the future, we're going to be launching a few months down the line a fully offline version as well, because right now both Apple and Google, especially on some of the higher end devices, have a really nice model personalization slash training capability with TensorFlow or with CoreML. So we're going to, utilize that and try to do all of the training offline. What has been very challenging for us has been objects. We would love to build, we would love to give Envision the ability to learn different objects in your environment, so that, for example, if you have like a particular cup or that you drink coffee from every day, it can go ahead and differentiate that versus the other
Mhm.
cups that you might have in your house, right? But that has been particularly challenging for us because we've tried zero shot or few shot learning methods. All of those things kind of work great on paper, but again, we don't have anything that can work reliably well in different lighting conditions, in different backgrounds. So it's been a challenge to build the teaching objects part, but teaching faces is a solved problem that I think pretty much anyone can just Google that stuff up and have a system working in like a couple of days. Yeah. I
Yeah,
mean,
yeah,
like when we first launched it in 2017, 2018, that was fairly novel. But now it's like you have a lot of proprietary, like you have Amazon, Google, and all of these guys also offering similar things that you can use as well.
yeah. Nice. And yeah, I guess the fact that you can iterate back and forth between the device and off it, like obviously that makes things much
Yeah.
more flexible.
Yeah, and now you have much more like now you have more things that you can do offline with less effort. When we started, we had to like do a lot of work to make anything work offline. Well, for example, if you wanted to make our OCR engines work offline, OCR engines are like all multi-stage pipelines in the very beginning, so it was incredibly hard to do all of that offline. But over a period of time, what we have seen is that, yeah, like the because of advances in the architecture and in the way things are done in general, and also advances in the general tooling itself, like TF mobile or TF Lite has itself become much more advanced from the beginning. So it's made it easier for us to deploy all of these on device. And today, I think for anyone starting out to build an ML product, it's actually really simple. You have so many tools, even you guys like ZenML. I mean, ML ops is actually a well-known like area that is kind of coming up. But when we started first, everything had to be done by hand. And what was the sad part is that a lot of those things kept getting outdated in like 6 months time, because somebody will launch something like an open source library or an open source like company would come out, and then or the work that we put in to build those stages would just get completely outdated, and I would just hit myself in the head every 6 to 8 months thinking like, why didn't this thing come 6 months ago, right? Yeah. So
Yeah.
that's one of the things that luxuries you have today.
Yeah. Yeah. I'm kind of curious, like, what are the other kind of big challenges you face in terms of like just the engineering of this? Yeah.
I think what remains the biggest challenge for us is deploying stuff on device, and really, ensuring that the models are updated consistently across different versions, across different platforms. The challenge with deployment earlier was the lack of, tooling and the lack of things that has kind of evolved slowly. But now the expectation that a lot of our users have is that this stuff needs to work offline entirely. And as you as we are becoming a company that sells more to enterprises than directly to customers, that requirement has actually moved up a notch, right? For example, we sell the glasses to hospital networks, and hospital networks, no matter how much you promise them, what kind of SLAs you want to sign with them and things like that, they do not ever want to have a device that connects to their hospital network that talks to external systems, right? And we're still a small enough company, and we don't have the bandwidth to like deploy stuff on premise, and we can't go into a full blown enterprise offering just yet. So we have to try and make more of our complex models work offline on the Google Glass, which is basically a device which is stuck in 2019, right? Like that's the state of the art of that device. It's not evolved since then. So it's the biggest challenge that we face. So, and when you do stuff offline, people still expect it to work well enough. And even if you can, basic quantization techniques just don't cut it anymore. So right now, we have our own quantization flows where we go deeper into. So we at this point right now we stopped working with even open architectures unless they're really good and unless they can solve very generic problems like object detection and stuff like that. That's when we work with open architectures. We started working with our own architectures. We started looking for our building our own architectures and owning that also in house, because that means that we can be more in control of the quantization process, which means it makes it easier to deploy those models on device. So that is what tends to be like the biggest engineering problem. Second engineering problem that we face is building data collection pipelines, within these really low powered devices, right? When earlier, we used to have stuff deployed on the cloud, the requests used to come into the cloud, and from there you could basically go ahead and like things like take care of things like storing the user data based on the user consent and all those things. But now when more of this stuff happens on device, how do you actually go ahead and send data from the device to the cloud whenever there is a network, whenever there's spotty network, because you can also not go ahead and store data on the device forever. How do you know which data to pick and which data to not pick? So those are the some of the more difficult engineering problems that we are actually looking to solve, that we're solving today, right? So the deploying on device and collecting data from edge devices, bringing that back onto the cloud and putting them into the data pipeline are like some of the really big challenges that we have. And of course, I'm just talking purely about the ML side. There's also the other side where you know since the apps that so our apps are looking to go free. I think by the time this episode might come out in a few weeks, yeah, our apps would be free. We used to have a subscription model for the apps, and now the apps are free. Because we've been able to bring more of these on device, our cost to have the app is actually quite low. But still, there are like significant backend costs that we'll also have to consider, and we'll have to like redo the backend of the app to be based on a serverless architecture rather than EC2 instances, because then we're going to be paying more for it. But those are more like regular engineering challenges. But going forward, these kind of challenges are becoming harder and harder to solve. Specifically, for example, we're trying to deploy a scene description model, an image captioning model on device right now. And it used to be on the cloud earlier, but the expectation from users has changed to having it on device, especially when we're selling it to these hospitals and hospital networks and things like that. And we're in the process of trying to really redo our image captioning model from the ground up. All of these different things like building our own architecture, figuring out how quantization works specifically for us, and trying to really bring them on device. So that's like a specific engineering challenge that we're having at the moment.
Hmm. And how do you feel the world of tooling is supporting those challenges? Because at least from my experience of some of these things, it's like it's not quite there. We're not a lot of the tools, and it sounds like you're just building a lot of it yourself.
Yeah, definitely. I think the tooling lacks. So what I find is there is a lack of one uniform format that kind of works across the board. So what I mean is, for example, um, or one uniform tool chain that can work across different platforms or is platform agnostic. For example, we have to build our own data pipelines. So the whole process of pulling data from edge devices, bringing it onto the cloud, and then really going through the motions in terms of applying some processes to clean the data automatically and then put them into a silo. So those we've not been able to find sufficient tooling in those areas. That's one thing. Second thing is even deploying models on device, we still have a very primitive versioning system that we use to deploy models on device. So we use say for example Firebase, which is really common mobile backend platform, and we have our own versioning scripts and things like that to basically pull these models onto device and so on and so forth. And even collecting feedback about the models, we'll have to again build our own pipeline for collecting feedback about specific images or specific operations back into our own analytics funnel. So these are like the 3 or 4 areas where I'm seeing that there are different companies that do very well in one space or the other, but it's kind of hard to find a company or find a set of tools that work very well with each other. There seems to be no open platform for being able to do these things, which is what I wish existed. Yeah, that's basically what I see. That's where we spend a lot of our engineering effort trying to do. We don't want to do that. We would ideally want to have a set of tools that can do this by automatically, but or with a bit of plug and play. And even if it costs us, that doesn't really. It would still save us a lot in terms of the man hours we take to build different stages of the pipeline.
So I can imagine, particularly dealing with a device like this, there are some kind of very specific and kind of real like risks that you have to think about when designing and working on this, whether it's in terms of like giving people the wrong information or telling them that they can walk in this place or not, or that this is a safe thing to touch, or I don't know exactly what this is. I was wondering maybe you could talk a little bit about that risk environment and whether like how much of it is like constrained by like the law versus just your own assessments of that.
Yeah, sure. So I think first of all, we try to avoid situations where we know that a user's life might be at risk. For example, one of the things that people always ask us is why don't you do navigation? Even some of the interns that we have for machine learning, they're so enthusiastic. They're like, yeah, you could take this particular segmentation model that people use, and then just try to go ahead and slap it onto the glasses, and you can have autonomous walking, right? But we don't do that because we know that there are massive risks in telling a customer that okay, it's red light or green light when they're standing at a pedestrian crossing. It's something that we never want people to rely on our device for at this point, especially because all we have is the camera. We don't have other onboard sensors to kind of validate that. We can't bring sensor fusion into this right now. So that's the reason why we don't do navigation at the moment with Envision. So that kind of is where most people are wary, or I would be very wary of machine learning trying to solve those problems with just the camera as the primary means of input. On the other hand, we heavily rely on users to guide us on what kind of outputs are ideal for them. So what we do is after every X number of usages of the app or the glasses, we just ask them, this last output that you got, was that okay for you or not? We do that a lot more with the beta testers. as well. So when we deploy a new version of the model, we ask beta testers about, like we have a big beta testing group about like 2,000 people who are currently using a beta of the Envision app. So we go ahead and tell them, like, ask them questions. How did you find this? How did you not find this? Can you give us more information, about what kind of, how you were happy with the output, how you were not happy with the output. So we do a lot of quantitative asking of the users to guide us on how well a model version is particularly performing or how well a feature is performing. And we also do a lot of in-house testing as well. In the case of working with people who are blind and visually impaired, especially if you yourself are not blind and visually impaired, you have to do a lot of in-person qualitative testing as well. So at the end of every quarter, we basically assess the accuracy of all the models that we currently have deployed on the app or on the cloud, and we use these metrics to guide us. Like the actual feedback from the users about how accurate a document has been scanned, how easy was it for them to be able to scan that document, or did the table that they read just make sense to them. So those are all, like the metrics that we track and use to assess how good the model is working in production. And of course, we also periodically test the model. We keep updating our validation set, and we keep periodically testing our models against those validation sets, so that we ourselves have like a very objective mathematical idea of like how well a model is performing versus not. So these are some of the tools that we use in the open. It becomes challenging because, unlike other machine learning apps, you can't the user can't see the output and verify if the model is actually doing a good job or not, right? It's basically based on the knowledge of the user who's trying to scan the document about what the document is, that kind of guides us whether their output could be good or not, and it also guides the user to know whether they're actually getting the right output or not from them. Yeah.
Yeah, because I guess like this whole reliability and trustworthiness of your models, like it's as much an engineering product, project as it is anything else. You need to be able to like feed all of that feedback back into how you're developing the models. Then,
Yeah, no, that's so true. Which is why, like in Envision, I think the computer vision role is so much more than just computer vision. I think it's a lot to do with also understanding the users, understanding the problem that they're trying to solve, and actually really understanding the problem from the user's perspective when working on the model, or when working on the feature itself, right? And the way we do it at Envision is that we give a engineer full ownership of that particular feature, right? So they go right from designing or understanding how the designers work with that particular feature, what the expectation from the users are, to how it's going to be deployed with the platform engineer. So they get a very holistic idea of how to build something end to end. Right now, when they're wanting to work on a particular machine learning feature, I think that's the way we would go into the future as well, right? At some point, of course, some things will get really big for just one person to work on, but the kind of niche problems that we're tackling, one person can actually take it end to end, and that gives them a very holistic idea of the problem they're trying to solve. They're just not trying to take some particular notes from the designers and then trying to like build or create build something based on that. They're actually talking to users and also incorporating their feedback directly into the work. So yeah, it's one of the perks of being in the startup space, phase, where you're small enough to still work on problems end to end, so you have a very deep understanding of the problem. At some point, if we get much bigger, then yeah, we'll have to start compartmentalizing it. But right now, we ask one engineer to take a feature end to end, no matter how long it takes.
um, I'm curious before we go to the final two questions, if you were to take a bit of a step back in terms of like the things that you've learned over the past few years, like what would be some core lessons that you would take away from what it means to put models into production, and how to do this in a
Mm,
useful way?
mm. Well, I think the biggest lesson that I have learned in taking models and putting into production is understanding the problem really well, and understanding the problem holistically. I think as an engineer, especially if you're someone who's wanting to build a machine learning or AI based product to be put into the hands of people like customers in general, I think it's kind of becomes easy to just look at it as a technical problem, saying, okay, it's an OCR problem, or it's an object detection problem, or it's a classification problem. It's very easy to sort of put or have a very technical lens to all the things that you hear customers talking about, or the problems they face. But I think having a deep understanding of why they want to solve that problem, why is it important to solve that problem at this point, what are the constraints that you have to work with. I think that's also a very important thing as part of understanding the problem, is what are the primary constraints of the problem itself. Is it something that needs to be happening on device? Is it needs to be happening online? What is like the real use case for it? Even though you might be an engineer who is just building stuff, maybe you're a slightly bigger company and you're just working on a piecemeal part of the problem. I think it's still very important to understand the problem. I think that's the one thing I wish I had done very early on, is to just immerse myself in the problem more before starting to actually go into the research and into the development and so on, right? Because that would have saved me a lot of time in the past with some of the mistakes that I made when it comes to solving problems. And I was just impatient. And I think just being patient, immersing yourself in the problem, and truly understanding what you're trying to solve, um, it's not just the job of designers to do that. I think it's also the job of engineers, especially computer vision engineers, because I also noticed a lot of times that communication is an important skill to have if you're a computer vision engineer, because a lot of times in the ML space, people outside the ML space don't really know what is possible to do with ML models at this point. So you have to be the one to understand the problem really deeply and explain the options to the engineering team, or to the design to the design team, right? Um, I've seen so many, interesting solutions. I've seen so many different, I've seen features get completely changed inside out when the computer vision engineer starts to understand the problem and suggest that, hey, you know what, I read this paper and they have this new way of doing this, and that can work on the glasses. So that gives the designers like, oh wait, I didn't know you could do that, right? Because again, machine learning is still such a technical space that it's not very easy for people outside this space to penetrate and understand. And if you are someone who understands the problem well, and if you're someone who can communicate the different options available to the rest of the team, or to the business folks, I think that makes a huge difference in how a product gets built, or how a feature gets built. And that can change the course of the product or the feature itself. And so it's important for the machine learners, especially the practitioners, to be good at communicating as well. I think that's the like I think understanding the problem deeply is the most important thing that I have learned. And being able to communicate the constraints, and being able to communicate the options to people outside of the machine learning team, so that they can make informed product decisions as well. That is also like a really important thing. I think some of the best work that we have done have come from engineers understanding the problem and really opening up the door the options for designers to start building stuff on.
Mhm. Yeah, those definitely ring true. We usually like to end these podcasts with a couple of shorter questions, answer them in whatever way you'd like. So first off, what would you say, or what would you recommend as a quick win that someone can add to make their productionizing of models just more robust?
I think it's a quick thing that they can do. Um, hmm, wait. I think well, it's a bit. I can't think of anything at this point. Oof, yeah. Like I can only think of very specific things that we have done in the past that has really helped us. I think to productionize the model, I think the first thing I would say is build a least shortest path from taking the model from within a Jupyter notebook to getting it into the form of an API, right? I think that's the first thing that we always do. If it's all in Jupyter notebooks, then it's very hard for the engineers to understand how things work at some level. So I think so we use, for example, Gradio and all of these other tools, to like quickly, get the model out of the Jupyter notebook, or even use a Jupyter notebook itself as a server of sorts. But yeah, the first step in productionizing is prototyping, and the first step in prototyping is really just building the basic API around the model itself. Yeah.
Yep, I think that's good and not done often enough, I guess. And what would be one part of putting models into production that you think people building tools in this space need to give a bit more attention to?
If the models are going to be deployed on device, it would be really interesting to figure out ways that can help the practitioners who are putting the model into production try to build make it easy for them to build image pipelines, or even data pipelines from edge devices, and to whatever data pipeline that they're using on the cloud, because that part actually is still something that I know a lot of other companies do like custom tooling for, which could be something that people who are in the tooling space could look into and say, okay, if these models are going to get deployed on the edge, how can we best help build data pipelines, from the edge devices over to the cloud and so on. Yeah, that's one, at least one particular problem that we face quite heavily.
Great, thank you. So yeah, I guess thank you very much for coming on. And if people want to check out what you're doing and stay in touch and keep in contact and so on, like how will they go about that?
I'm a Twitter addict, self-professed Twitter addict. So, I think I can ping you my Twitter handle, and you just put it in the show notes. That's the best way to get in touch with me. I live on Twitter, so yeah, that's probably it.
Okay, great, thank you.
Yeah, thanks so much.
Okay. Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.